Hello everyone, welcome back to the channel. I am the EE Guru. Today I'll be covering equivalent resistance. And this is a very important topic because up until now, we've been working on solving simple circuits that had one or two resistor components. And these circuits were either purely series circuit or purely parallel circuits. Unfortunately, in the real world, most circuits are not simple circuits. Most real-world circuits have multiple electrical components, and these components are configured with a combination of series and parallel components. As we transition into solving more complicated circuits, this idea of equivalent resistance will be crucial because it will allow us to simplify complicated circuits into more simple circuits. So let's dive right on into this. So what you need to know about resistors in series is that their equivalent resistance is just the sum of their individual resistance. So if we take a look at the circuit on the left right here, we see that we have 5 resistors and they're all in series with one another. So this circuit right here can get simplified by getting the equivalent resistance of these 5 resistors. So what is the equivalent resistance of these 5 resistors right here? RQ in this case will be equal to R1 plus R2 plus R3 plus R4 plus R5. In this case right here with this circuit, the equivalent resistance will be R1 plus R2 plus R3 plus R4 plus R5. And now, once we have the equivalent resistance, we can simplify this circuit into a simple circuit. So this is the simplified version of this circuit right here. We were able to get the equivalent resistance of the more complicated circuit and simplify it into a simple circuit by using the equation of getting equivalent resistance of series resistors. Moving on to parallel circuits. So what we need to know about resistors in parallel is that 1 over their equivalent resistance is equal to the summation of 1 over their individual resistance. So if we take a look at the circuit on the left right here, we see that we have 4 resistors in parallel. And we know that we can simplify this circuit by getting the equivalent resistance of the 4 resistors in parallel. So we know 1 over Req, the equivalent resistance, is equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4. So this is equal to 1 over equivalent resistance. So in order to get the equivalent resistance, we have to get the reciprocal or the inverse of 1 over Req. So we do this by setting this equal to -1. So what do we do on the left side? We have to do it on the right side. And we get equivalent resistance, which is Req, is equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4, all to the -1 power. So this is the equivalent resistance of these 4 resistors in parallel. And now we can redraw the circuit as a simple circuit where Req is the equivalent resistance of the 4 resistors in parallel. So now we're going to get into simplifying more complicated circuits. So the circuit that we have below right here has a combination of both series and parallel resistors within the circuit. So the way we're going to go by simplifying this circuit into a simple circuit is by breaking down this circuit into smaller chunks of smaller simplified circuits until we get down to a simple circuit. So taking a look at this circuit, we see that we have R3 and R4 in series. So this can be simplified. So this entire circuit can be simplified to this circuit right here. Where R34 is the equivalent resistance of R3 and R4. And we know that the equivalent resistance of R34 is just R3 plus R4. And this right here is R1, and this right here is R2. So we simplified this circuit down into a simpler circuit where we have 3 resistors. And we see right here that R2 and R34 are in parallel. So what we're going to do now is we're going to get the equivalent resistance of R2 and R34, and we're going to call that equivalent resistance R234. So we see that the previous circuit gets simplified to this more simpler circuit. But we can even simplify this circuit even more by getting the equivalent resistance of R1 and R234, which we see that R1 and R234 is in series. So their equivalent resistance is just the sum. So this circuit simplifies into R1, 2, 3, 4. Where R1, 2, 3, 4 is the equivalent resistance of all the resistors within the original circuit. So that's the video. Don't forget to like and subscribe. Next video, we'll be working on example problems to drive home the concept of equivalent resistance. So I'll see you guys in the next video.